How do you do, ladies and gentlemen, and boys and girls and teachers? I'm Julius Sumner Miller, and physics is my business. And my program today has to do especially with this: how to produce electricity. And I call to your attention the quotation marks in the word for the word produce. We do not really produce electricity. The electric stuff is always there in abundance. Always. Positive and negative charges. All we do is separate them by some means and thus make available what we call a difference of potential, whereupon if we connect the points where the charges are gathered, we have a flow of charge, which we call an electric current. Now the question is, how do we produce an electric current? Let's go to some absolutely primitive things. Here I have a lemon. So somebody says, now, what are you going to do with a lemon, Professor? I'm going to make an electric circuit, produce electric current. I have here a slab, a sliver of zinc. I'm going to stick it into the lemon. I have here a sliver of copper. I'm going to stick it into the lemon. Notice the requirement: 2 different metals and an electrolyte. A solution which makes available some stuff for electric migration. Here is a meter, a very sensitive galvanometer, a galvanic meter. Its purpose is merely to detect the existence of an electric current, not really to make any measurements as to how much it is. I'm going to connect this meter to the zinc electrode and another terminal of the meter to the copper electrode. Now watch that meter. Watch it. Oh-ho! There you are. Now I'm going to exchange the polarity. Watch it now. Direction the other way. So, this that I have here, an acid solution and 2 different metals, we call a voltaic, V-O-L-T-A-I-C, a voltaic cell named after that wonderful Italian Alessandro Volta of Como, Italy, who is commemorated indeed in Como with a temple to Alessandro Volta. Now, I say, 2 different metals and an electrolyte. Observe the following. The saliva in my mouth is an electrolyte. I have here 2 different metals. I'm going to put these 2 metals in my mouth. Watch the meter. Watch it very closely. Watch. Watch. Got to see the meter. Aha. There was a motion of the needle. So you see, the acid solution in my mouth is the electrolyte and 2 different metals. Question: can I get an electromotive force, a difference of potential, from a grapefruit? Yes. Can I get it from an orange? Yes. Can I get it from an apple? I won't answer that. And how about getting it from a potato? So what determines, what constitutes a voltaic cell? Answer: 2 different metals. Here I have copper and carbon. Here I have carbon and lead, as long as I have 2 different metals. Now, supposing I have 2 identical metals, lead and lead, in an acidic solution, in an electrolyte, will I get anything? Answer: no. So the question arises, all the plates in your storage battery are lead plates. How then come we get any electrical energy from a system which is all 1 metal? Answer: it is not all 1 metal, because when the battery is charged, some plates become different from other plates, and thus we provide 2 different kinds of plates. Voltaic cell produces electricity. How else? Wonderful thing. Let me take 2 different kinds of wires, any 2 kinds of wires. Whoop, I'm tangled up here. Here is a wire, there's a wire. Let this be copper wire and this iron wire. Let me make the ends in one junction, and let me connect the other ends to a galvanometer, such as we had already. Let me make this junction at one temperature and this one at another temperature. What do we have? A thermocouple, and it produces electric energy. It gives rise to a difference of potential. Proof. Here I have two different wires connected to a 0 centimeter, and here is one of their junctions, and I'm going to warm this junction. I heat it with a match. Watch the needle. Watch it. Do I have to turn that to the... Watch it. There it is. A thermal EMF, an electromotive force due to a difference in temperature of the junctions of the thermocouple. Consider a dry cell with which you're all familiar. Dry cell. I want to write that word on the board. Dry cell. Whoop, little disaster. Dry cell. I put the dry in quotation marks. Why? The cell is not dry. It has some pasty stuff in it, manganese dioxide and other, which makes it a wet cell, but it's always sealed up tightly on top so as to keep it from oozing out. Now, what constitutes a dry cell? Answer. The central pole is carbon, the positive pole, and the can which holds it all together is zinc, and thus do we not have a voltaic cell made up of two different metals. How else can I produce an electric current? Well, here is something which is absolutely enchanting. In 1831, Michael Faraday, my beloved Faraday, whose grave I visited 2 years ago in London, Michael Faraday discovered the following. Let me have a coil of wire, and let me connect it to a sensitive detecting instrument called a galvanometer. Notice that name, galvanometer, named after Luigi Galvani, who was, in fact, a contestant with Alessandro Volta regarding the nature of electricity. So I have a coil of wire. Let me take a bar magnet, whose polarity is so. Let me thrust it into the coil. Ho-ho! We see the needle move. Let the magnet be at rest. Needle returns to 0. Let me pull it out. Needle deflects the other way. I have an alternating generator. Watch it. Here is a coil of wire whose ends I have connected to this meter. Here is a bar magnet. Watch the meter. We should see all the system. Notice when the magnet is at rest, there is no change of magnetic flux, and therefore no current arising, no difference of potential. Now let me double the magnets. I doubled them. But if you noticed how they went together, it is obvious that the north pole of one has annulled the south pole of the other, and if they are of equal pole strength, we should get nothing. Watch it. Very feeble. Very feeble. Now let me put them like pole to like pole. Notice they are repelling each other. I'm going to squeeze them together. Now we should get an additive effect. Watch it. Notice it requires motion or change of magnetic flux threading the coil. Or let me take a real strong magnet and use this as a bar magnet. Watch it now. Ho-ho! Notice, no motion, no EMF. Let me move out of the way of that camera. So there I have an alternating generator. Instead, then, of moving a bar magnet in a coil, supposing I had a coil of wire wound on a frame, and I had a handle, and I could turn the coil, and I could encircle that coil with a magnetic field. I would have a magnetoelectric generator. I have one here. There is a coil inside here, which I can turn with a crank. And you notice I get enough difference of potential arising to excite, light, energize an ordinary incandescent house lamp. There it is. Now, I am going to increase the magnetic field that envelops that coil. Here I have a strong Alnico magnet. I'm going to couple the fields. Watch now. Watch the lamp. Ho-ho! The lamp does not light at all. What have I done? Obviously, I have the polarity here annulling the polarity there so that the field is nearly zero. Let me turn this one around. That way. And now watch. Aha! The lamp is brighter. Now that current that I have generated there is an alternating one. Proof. Here is a two-pole lamp. A lamp which fires first on one side and then on the other. Watch it. Uh-huh. Uh-huh. How many see? 2 things, 3 things, 4 things not right? 1, the lamp has too high a resistance. Maybe the field isn't strong enough. Or maybe I don't turn fast enough. Oh, there's a little flicker. I'm going to fix it. I'm going to fix it. There we are. There we are. And you notice the alternations which make clear that it is an alternating current generator. Right? Question. Very exciting question for students to contemplate. Supposing I had a vessel, glass, in which I put 2 different electrodes, say zinc and copper, and I connect them to a galvanometer, and I have an electric current, as we witnessed on this arrangement here with the lemon and the 2 electrodes. Supposing I had these slabs as big as a barn door, and this vat here as big as the cellar of the Empire State Building. Would I have any greater difference of potential or greater EMF? Answer, no. The 2 different metals in the electrolyte, which is the same for all our adventures, gives us the same EMF, which suggests the following. Supposing I took 1 little drop of that electrolyte, 1 little drop, and I put 2 little slivers, 1 zinc and 1 copper, in that 1 drop of electrolyte, I would have the same difference of potential there as there. So somebody says, well, why do batteries have to be as big as they are? Answer, longer life-producing energy, or energy-producing life, whichever you want to get at, however you want to get at it. So, of all the means of producing electrical energy, making available electrical energy, chemical is the principal one, but more used throughout the world is this electromagnetic induction of Michael Faraday, which we call magnetoelectric generation. And I thank you for watching.